We are looking at our final section, and we are going to be solving equations that involve radicals. So let's go ahead and get started with this first example. You'll see that we have radicals on both sides, and in the middle there is an equal sign. And when there's an equal sign, the way that we try to move forward is to solve, to get the letter that we have, in this case n, all by itself. Now there's n's on both sides, so that's starting to look a little tricky, and since we have these square roots here, we need to find a way to essentially make them go away. Easiest way to undo a square root is to square it, and if you do something to one side of an equation, of any equation, you have to do the exact same thing to the other side. So in this case, if I take this entire side and square it, I would have to take the other entire side, put it in parentheses, and square it as well. Now the square root of something squared is going to undo each other. It is like saying 7 plus 3 minus 3, or 5 times 2 divided by 2. The same way that times and divide are opposites, the same way that add and subtract are opposites, squaring and square rooting are opposites. So we get the exact same thing we started with, just without square roots. Now what's handy is I can continue working forward to actually solve the problem. In this case, this n is really a 1n, so I'm going to write the 1 out front so I don't get confused. And if I were to try to get the n's together, so my goal at this point, get the n's on one side, get the numbers on the other, I'd probably try to move my n's over to the left. So I would subtract 1n, or add a negative 1n to both sides. When I do that, I have negative 1n plus positive 3n is going to equal 2n, and then minus 12. On the other side, I have a positive 1n and a negative 1n being added together, which equals 0n, or just 0. I still want to get n by itself, so I got to get that constant, that number, away. If I have a negative 12, I need to add a positive 12 to both sides, so let me do that. And when I add a positive 12 and a negative 12, I get 0, so that just goes away, leaving me with just 2n over there. Over here I have 0 plus 12 is 12. And for my final step, I need to get n alone. And since n is being multiplied by 2, I get it alone by doing the opposite of multiplication, division, the inverse operation. That leaves me with n equals 12 divided by 2. 12 over 2 is a fraction, is just division, meaning that we have 6. Now, it'd be nice to say that's just my answer, but it says this weird little note here. Remember to check for extraneous solutions. What that means is that sometimes, because of the fact that you're squaring these problems, you are going to get weird things happening, as in that 6 might not work at all. It might actually just not have a solution of any kind. It might be impossible to solve. So we're going to take that 6 and plug it back into the original problem and make sure that it works. So I'm going to get rid of all of that there. And everywhere I see an n here, I'm going to put a 6. This is a good habit in general because it's always good to check your work. But in this case, there's actually a reasonable chance that it's just not going to work out at all. So I have 3 times 6 is 18 minus 12, and that's all under a square root. And on the other side, I just have the square root of 6. Well, 18 minus 12 is 6, positive 6. So the square root of positive 6 on the left is going to equal the square root of positive 6 on the right. So it's going to be okay. So I checked it, I'm moving on. What would happen in the strange cases, the cases where it doesn't work out, is I might end up with something like negative 6 under this square root and positive under that square root. And when you get something like that, your answer is not going to work out. You would actually have to cross out your answer if that were to happen. But in our case it didn't, so we just leave it n equals 6. Let's look for one more challenging example to work on, and we're going to go with number 42. In this case, we see a square root, and so we think we're going to need to square it to undo things. The challenge is that if we were to take this entire side and square it, we would have to distribute out to double distribute out this problem when we get some really complicated thing that was actually worse than what we started with. So we don't want to do that. What we want to do is get the part with the root all by itself first, and then when the root is alone we can start squaring. So if I want to get that part that I drew a box around all by itself, I need to get rid of that plus 10. And in order to get rid of a plus 10, we need to add a negative 10. And when we do that in the equation, we always do it to both sides. So if I add a negative 10 to both sides, my left side becomes plain old square root of n over 2. I have my equal sign because positive 10 and negative 10 are going to reduce to 0. And then 11 plus negative 10 is going to be just positive 1. Now the root is completely alone on the left side, and so I'm going to square this to make the root go away. Whatever I do to one side I have to do to the other. Even though that's not a square root over there, I still have to square it. So over here the square root and the square undo each other, leaving me just n over 2, no root. Over here I have to square the number 1. So I take 1 times 1, and in this case happens to be 1. Now if there were like a 3 in there, I would have got 9. So don't assume that this is always going to stay the same like that. Most of the time it actually will change. So n over 2 equals 1. Finally, I need to get n completely alone. So I got rid of the root, but I need to get n alone here. And n is being divided by 2. To undo that, I need to multiply by 2. Do it to one side, do it to the other. And when I do that, I'm left with just n. On the other side I have 1 times 2, and that's just going to be 2. So n equals 2. Again, we checked the very original starting problem to make sure that it will work. So I'm going to plug a 2 in here for n. 2 divided by 2 is 1. 1. The square root of 1 is 1. 1 plus 10 is 11. So that works out too. So no problems to worry about there. Some places where you're probably going to run into challenges, I would be careful with this problem right here and this one right here. What you're probably going to want to do is, you have multiplication on the outside, you're going to want to undo that multiplication through division right away before you start squaring anything. That's going to be true of both problems. You're also going to want to be careful with this one because it's got a minus 4 out here. You're going to want to get rid of that somehow. You're going to want to undo adding a negative 4 to both sides so that you get the square root of n by itself. Alright, good luck with these.